And so now the stage is for an Austrian artist and programmer who is leading an open source laser cutter program, Stefan Hechenberger.
What's up, Rome? How's everybody doing? It's late in the day, so I'm trying to speed it up a little bit. My talk is about Lasersaur, which is an open source laser cutter, which you can build yourself tomorrow if you want. It's very applicable to, sort of harnessing the maker in you. And when I say this, I don't mean this as a product that you use. You build the machine and then you have a machine, but also the process is very stimulating for makers. Like everybody should probably know who built a CNC machine before. As I said, I'm Stefan. Here in the middle, this is Eddie. We run a research and development studio together called Nord Labs. We also started the Lasersaur together. And to give you a little background story, everything started in 2010. We basically had access to a laser cutter, got really used to it, started for cutting pizza and opening letters and design work and prototyping. And we left the place and we didn't have a laser cutter, and we looked into the options, and there wasn't really a good commercial solution for us that worked for us. For one, they were too expensive. We had objections about the software they used. They were not cross-platform, and most importantly, they were lacking a sort of a vibrant user community. You get very, very spoiled when you're using projects like Open Frameworks or the Arduino project, where you have so much support and people run into problems and share them. So 6 months later, we had our first prototype from deciding to build our own, because this was our only really viable path. And we didn't know it at the time that this was sort of the easy part, to just get the machinery working and the technology. Everything started once we sent out kits to other people. So we had initially 20 kits. It was like as part of a Kickstarter campaign. We were very early participants in the sort of Kickstarter. Back then, still an experiment. We didn't know what Kickstarter was. And we sent out those kits. We had 20 people building Lasersaurs worldwide. And then it really started becoming interesting, because we got all this feedback back. And we decided to take it seriously and work it back into the design. So what is the laser cutter? What is the Lasersaur? It's a fairly big machine, yet lightweight. 2 people can carry it around. It has a 1.2 by 0.6 meter cutting cutting area. It has a very powerful laser system in it. You can cut up to 18 millimeters spruce or 12 millimeters of acrylic, all kinds of other materials. It has precise control. You can etch like the top layer of paper or wood. It's fairly precise. It's built from very readily available, reliable parts. So we don't sell the complete kit. We just give you a bill of materials, and you order most of the parts from standard companies. There are few custom parts which we provide, but you can also machine them yourself. They're all planar. There's a simple electronics board, which is a through-hole design, which means you can easily solder it yourself, or we provide that also if you want to save the time. It's optimized really for hackability, so we separate the software of the real-time subsystem from the software that generates the interface. The whole thing is very compact, and it wires up with Ethernet patch cables. So the Ethernet patch cables is really an example of how we approach the design. We try to reuse very common parts that are easy to buy from eBay or from your next store, and that are generally very cheap. This is the software. It completely runs in a browser, so it works really well in a shared space. Basically, you can switch on the Lasersaur, plug your laptop into the local network, and go to lasersaur.local, and you get the whole interface right there. There's no application you have to install in your laptop or drivers or anything like that. So it really works well in a shared space, like a hackerspace at the university. We built the whole software stack from ground up. So we built the whole firmware and the interface, which gives us like a lot of ways to like really tweak it and take in recommendations from the community and change it. And also, if you're a web developer, you can change the interface because it's based on web technologies. We can do crazy stuff like this. It's something we call laser tags. You can embed the cutting parameters right in the file, in your design file. You can say, okay, red and blue cut with 550 speed and 90% laser intensity, which is very useful. Lasersaur project is more than a laser cutter. It's a helpful community. We have a large email list. It's an infrastructure project, and luckily I don't have to talk much about that because previous speakers talked about how important it is that you have this open community who can share ideas. And also, this, I think Mark mentioned it, sort of the singularity. Once makers start building tools for making more, you have really a sort of a rapid increase in productivity. It's also a technology toolbox, so it's great for nerding out and hacking around because you're dealing with mechatronic systems like electronics, circuit board design, web interface, low-level real-time systems programming, optic systems. So it's a really quick way to get going and have something tangible and play with the technology. I would like to present you with some of the milestones. We have significantly increased the number of cutout Lasersaur, like dinosaurs. We have significantly increased the number of people in laser protection goggles watching lasers. We have also significantly increased the knowledge about different kinds of fire extinguishers. So at this point, I would like to talk about sort of safety concerns. Is it dangerous to build your own laser cutter? And in the beginning of the project, we got a lot of criticism for that. Is it should somebody do that? And our argument was from the beginning that if you go through the process of really building the machine yourself, you're also a very good operator and a safe operator. And that has proven to be true so far. We haven't had any injuries. We haven't had any major accidents, nothing like that. Even though it's very common for laser cutters tend to burn down a lot. We talked to a lot of hackerspaces, and they had a laser cutter actually burn down because the parts ignite and nobody's watching it. The best part is you can build it yourself. It's a lot of steps, but it's a series of easy steps. The process is you go to the website, get the channel overview, what to expect, read a little bit up, and then you go to the bill of materials and order all the parts. Total cost is about 7,000 USD and or euro. It's the same because in Europe everything is a little bit more expensive in that regard. 2 weeks later, you get a pile of parts. You get a freaking laser. And then you start building. And the way this works is the instructions, and you follow the instructions, and if something is not clear, there's a 3D CAD model. You can figure out all the details. And this is about as hard as it gets. This is the laser head assembly. Looks like that as physical parts. And start building the frame. Put in the laser. And after a while, you have a finished laser cutter. So let me show you some systems that are out there. They are mostly at universities and hackerspaces, as I said. Also, there are quite a few design studios and a few businesses that have been started just with like, okay, I'm going to get a laser cutter and start a business with it. This is our setup at Nord Labs. This is at Carnegie Mellon University. This is as we speak, CMU, Beyond AO, CMU again, Aeronautenwerkstatt. This is ETH Zürich, which is notable because it's an example that you can scale up the size of the laser cutter. This one is bigger along the y-axis. This is Hyperwork in Switzerland, ITP in New York, Radish Research in San Francisco. And then what happens, especially with open source designs, people start modding. So here we have an early prototype, and next to it, sort of a beefed-up version with a different laser. Here's rotary axis, a different head design, really oversized, super amazing exhaust system, drawing mod, different laser. Then you come to the point to it, people start creating things, just lay stuff on, start cutting. So this one is notable, I have it in there. It's a company that was started building miniature models, and they run Lasersaur. They were the first ones to reach 3,000 hours on the Lasersaur within a few months, which means they run it like almost 70 hours a week. And we get it's a very valuable person in our community because we get so much feedback from them. Cut sushi paper, more drawing, a mold for doing concrete tables that was built with a Lasersaur, architectural models, very intricate cutting, more plywood, and this concludes my talk. So I don't think in this format we have time for questions, but you can hit me up afterwards or write me an email. Thanks to our supporters, our early adopters especially. Without them, it wouldn't have been possible, and different institutional places. Thank you very much.
Thank you, Stefan. Grazie.